Welcome to The Explainer. Today, we are stepping into the surgical theater. I want you to imagine, just for a second, that you are a highly trained surgeon. You don't just kick open the doors to an operating room, grab the nearest sharp object, and start throwing tools around, right? Absolutely not. You need precision instruments. You need steady hands. You need to dissect every single problem presented to you with absolute, undeniable surgical accuracy. And that is exactly the mindset we are bringing to this masterclass. We are tearing into Section 1.4 Validation Methods for Cambridge Information Technology and Computer Science. Whether you're tackling syllabus code 0417, 0478, 2210, 9618, or the rigorous AS and A-Level 9626, the strategy remains the same. This specific topic appears in almost every single examination series. It is a staple. And yet, incredibly, students bleed easy marks year after year. Let me introduce you to two typical candidates we see all the time. First up, we have Alex. Now, Alex is a hard worker, but when Alex sees a validation question, pure panic sets in. He overloads the page with raw computer science facts, basically pouring out every single thing he's ever memorized about databases without a single drop of actual analysis. He completely ignores the context. And guess what? The examiner's red pen just slashes right through it. Then we have Sam. Sam's problem is entirely different. Sam rushes. Sam reads half the question, completely misses the crucial command word requirements, and writes a beautiful, detailed answer for a question that the examiner wasn't even asking. It's tragic. So today, we're going to look closely at their flawed answers. We're going to correct them live, and I'm going to show you the exact blueprint required to transform your own exam strategy from superficial to absolutely elite. Okay, let's dive right into our procedural framework for today. Think of this as your surgical checklist. We're going to hit the core principles, move into the technical methodology, master systematic problem solving, push into advanced evaluative thinking, and finally, we'll cover the principal examiner warnings so you don't fall into the classic traps. Section 1. Core Principles, the foundation of validation checks. Listen, to truly master these IT concepts, you can't just memorize definitions. You must operate across three cognitive domains simultaneously: knowledge, application, and analysis. It's not enough to know what a tool is. You have to know exactly when and how to use it on the patient on the table. Let's start with a foundational tool, the lookup check. A lookup check is a validation rule that ensures data entered into a system strictly matches a predefined list of acceptable values. Think of a simple drop-down menu online where you select your country. If you try to type in a country that isn't on that official list, the system outright rejects it. Now, according to recent examiner alerts, candidates consistently confuse this terminology with other validation methods. The theoretical architecture here rests on precise definitions and causal relationships. Remember Alex, our fact dumper? Alex's biggest flaw is that he stops at the knowledge level. He can recite a textbook definition, but he cannot apply it to a given scenario. And Sam? Sam fails at the analysis level, because rushing prevents careful examination of how different data points actually interact with one another. So how do we correctly answer a heavy-hitting question about a lookup check? We use the PEEL framework. That stands for point, evidence, explanation, link. It's the ultimate computer science success blueprint. Alex's flawed answer usually just says something like, a lookup check uses a list. That gets 0 marks for depth, it's too vague. A top-tier student uses PEEL. Point, a lookup check restricts user input to a predefined list. Evidence, in the provided database scenario, the department code field uses a lookup. Explanation, this prevents typographic errors because the user can only legitimately select from valid codes like HR or IT. Link, therefore, this ensures strict data integrity before the record is ever saved to the database. Do you see the massive difference there? The PEEL framework literally forces you to be analytical. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Next up in our toolkit is the consistency check. Now this one is fascinating. It compares two or more completely different fields within the same record to ensure they logically make sense together. For example, if a user enters their date of birth as the year 2015, but their driver's license status field is marked as valid, the consistency check immediately flags an error. Why? Because a 9-year-old cannot legally drive a car. The data in field A completely contradicts the data in field B. The principal examiner reports emphasize a very strict rule right here. You must explicitly define these key terms before using them in extended responses. Let's look at Sam again. When Sam sees an exam question asking to evaluate the use of validation in this system, Sam rushes and just scribbles down, use a consistency check to stop wrong dates. Sam missed the specific command word, evaluate, and totally failed to define the actual term. An elite candidate, however, slows down and writes, a consistency check, which verifies the logical relationship between two disparate fields, should be implemented between the delivery date and order date to guarantee that the delivery does not impossibly predate the order itself. Always define your terms and then apply them directly to the scenario. Our third precision instrument today is the limit check. A limit check verifies that numerical data or date data falls within a specific predefined boundary. We are usually talking about an upper or a lower limit here. Just a quick side note, if it has both an upper and a lower limit, it becomes a range check, but a limit check focuses on just one strict boundary. For instance, an age field must be greater than 0. You can't have a negative age. Now, I want to give you a brilliant, vivid visual story method right now. This is a memory hack to permanently encode and distinguish these three concepts. You literally never mix them up under intense exam pressure. Ready? I want you to imagine an exclusive nightclub. The giant bouncer standing at the door holding a VIP guest list, that is your lookup check. You are either on his predefined list or you aren't getting in. Once you are inside the club, imagine two serious detectives interrogating a suspect, comparing his alibi with his phone records to see if the story logically matches up. That is your consistency check, comparing two separate pieces of information for logical flow. Finally, outside the club on the street is a bright flashing speed limit sign saying maximum 50. That is your limit check, a strict numerical boundary. The bouncer with the list, the detectives comparing stories, the speed sign setting a boundary. Lookup, consistency, limit. Lock that visual in your brain right now. You'll thank me later. Section 2, Technical Methodology. Let's move on and see how this builds our procedural framework. Having all this knowledge in your head is completely useless without a rigid procedural framework to actually apply it on the exam paper. You need to read the exam data precisely like a seasoned surgeon reads an X-ray, scanning past the noise, looking only for the anomalies, the exact data types, and the critical areas of interest. So here is the exact 5-step standardized sequence for processing any validation problem Cambridge throws at you. I am going to act as your strict surgical guide through this process. Step 1. Deconstruct the question. What is the specific command word? Is the examiner asking you to describe, explain, or evaluate? Because those require 3 totally different types of answers. Step 2. Extract relevant data. Physically highlight the specific fields mentioned in the exam scenario text. Step 3. Select the analytical framework. Are you bringing in our trusty Peel method? Step 4. Execute with clear notation. Step 5. Present with correct professional terminology. Let's do a live rewrite together. Imagine a typical past paper question asking you to validate a membership ID field, and the scenario says it is formatted strictly as 2 letters followed by 4 numbers. Our buddy Alex writes this. Make sure they type it right. That is an instant 0 marks. Let's run his answer through our 5 steps to fix it. First, we deconstruct. The question wants a specific method of validation. Second, we extract the data. We see it needs 2 letters, 4 numbers. Third, we select our framework. We identify that we need a format check. Fourth, we execute. Implement a format check or picture check. Finally, we present with terminology. The format check will enforce a strict input mask of LLNNN, ensuring the specific character types perfectly match the required data dictionary specifications. Boom! Suddenly, Alex's red pen marks transform into big, beautiful green check marks.
This brings us to a massive concept, the method mark strategy. This is absolutely vital for computer science and information technology exams. Listen closely. Marks are awarded for your process and your systematic reasoning, not just the final answer. If a question is worth 4 marks and you simply state use a lookup check, you might scrape by with exactly 1 mark for identifying the tool. But if you show you're working, if you use Peel to explain exactly why the lookup check is the most efficient choice compared to a format check and how it would be technically implemented in the specific database table provided in the prompt, you unlock all the method marks. Demonstrating clear working and a logical analytical process is exactly where the top points are won. The examiner essentially wants to see your brain working out loud on the page.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Welcome to Section 3, Systematic Problem Solving. Deconstruct, solve, evaluate. We are introducing the specific deconstruct, solve, evaluate problem-solving model required for high-level validation checks. It is time for our interactive workshop. We are going to put you to the test. Challenge 1, the data scan. I want you to imagine a complex data table on your screen. It's an employee database. It has 3 fields, start date, department ID, and salary. I'm starting a 60-second virtual timer in your head right now. Look closely at the relationships. If the scenario tells you the department ID is always MKT for marketing or FIN for finance, but you notice the salary field currently allows users to input negative numbers, what is the immediate flaw in the system's validation? Think about it. Scanning, time's up. The core trend you should have extracted from that quick scan is that a limit check is completely missing on the financial field because a salary cannot be below 0, and a lookup check is urgently required for the department ID to restrict inputs to MKT or FIN. This mental model forces you to scan data not just as boring text, but as a rigid system of rules just waiting to be broken by a user.
Let's look at how to apply this rigorous sequence to draw evidence-based conclusions from complex examination questions. Step 1. Identify given information. Step 2. Break into logical steps. Step 3. Solve systematically. Step 4. Check for reasonableness. Step 5. Make justified recommendations. Let's move to Challenge 2. Find the flaw. I want you to listen carefully to this flawed sample paragraph written by Sam and find the mistake. Sam wrote, "To fix the data entry errors in the system, we should add a limit check to the gender field so people can only type M or F. Where's the fatal flaw in that logic? I'm giving you 10 seconds. Tick, tock, got it?" The examiner commentary here would heavily penalize Sam. Why? Because a limit check is strictly for numerical or date boundaries. The gender field requires text. It needs a lookup check or a Boolean format. Using the wrong tool for the job shows the examiner a complete lack of systematic solving. Okay, Challenge 3, speed writing. You have exactly 30 seconds to mentally draft a perfect Peel paragraph justifying the use of a consistency check in an HR database. Timer starts now. Go. Remember the acronym: point, evidence, explanation, link. 5 seconds left. Okay, pencils down. You should be thinking something exactly like this. Point. Implement a consistency check. Evidence. Compare the date of hire field and the date of birth field. Explanation. This prevents logical impossibilities, such as an employee being hired before they were even born. Link. This maximizes overall data integrity in the HR module prior to processing payroll. That is exactly how you use this 5-step sequence and the Peel framework under intense time pressure.
Let's keep this momentum going into Section 4, Advanced Evaluative Thinking. This is all about moving from superficial breadth to analytical depth. I need to remind you that the academic benchmark for Cambridge 9626, and honestly for all the upper-level computer science codes, heavily prioritizes deep, structured reasoning over simply listing superficial facts like a robot.
There is a massive, grade-defining difference between basic knowledge and true evaluative thinking. It is frankly not enough to know 50 different IT terms if you can only write one basic, boring sentence about each of them. Superficial knowledge sounds like this. A limit check stops numbers that are too high. Okay, sure, it's true, but it's basic. It's an average grade. Now listen to how evaluative thinking sounds. While a limit check prevents upper boundary violations in the quantity field, it assumes the user won't enter a negative text string by mistake. Therefore, to be robust, it must be combined with a format check to ensure comprehensive data integrity. Do you see the massive leap in quality there? Top-scoring candidates constantly question assumptions. They consider different perspectives. They use cross-topic connections, linking validation methods to completely different chapters like database normalization, data security, or user interface design. Depth is exactly what separates the A-grade candidates from the C-grade candidates. When you combine your specific validation knowledge with your broader database architecture knowledge, your mark potential shoots all the way up to 100%.
We have arrived at Section 5, Principal Examiner Warnings. This is about avoiding the classic traps. I want to build a little tension here because we're about to expose the exact reason students lose easy marks on this topic every single year. Every exam cycle, Cambridge publishes Principal Examiner reports. Let me tell you, these documents are absolute gold dust. They tell us exactly, page by page, where students bleed marks. You have done the hard work of learning the theories, applying the Peel framework, and mastering the methodology. Do not let all that effort go to waste by falling into the predictable, recurring pitfalls that catch out thousands of candidates globally every single examination series.
So how many traps are there? There are exactly 3. 3 critical, recurring mistakes repeatedly flagged in the Principal Examiner reports for Section 1.4 validation methods. I want to be clear, these aren't minor spelling errors. These are fundamental breakdowns in exam technique that will cost you full letter grades if you aren't vigilant. We're going to look at each one of them right now so you can completely immunize yourself against them before you step foot in that exam hall.
Let's break them down. Mistake number 1, using the wrong approach for the wrong context. This is exactly what we saw with Sam trying to use a numerical limit check on a text-based gender field. You must match the surgical tool to the actual data type. Mistake number 2, forgetting to check format and presentation.
You might write a brilliant, highly analytical explanation in your head, but if your notation on the paper is sloppy or you don't present your working clearly, as we discussed in the method mark strategy, the examiner literally cannot award you the points. You have to make it easy for them to give you marks. And mistake number 3, and honestly, this is the most fatal of them all. Answers are not specific to the context given. So the crucial point is, if the exam question is explicitly about a hospital patient database and your perfectly written answer talks about validating barcodes in a generic retail store, you get 0 marks. 0. Context is king. Your analysis must always match the specific scenario provided in the prompt.
To summarize, the ultimate exam strategy direct from the syllabus guidelines, it comes down to this core philosophy. Deconstruct the question, extract relevant data, select analytical framework, execute with clear notation, and present with correct terminology. This quote firmly anchors all the key takeaways of today's explainer. We've built the complete analytical answering system today. You really just need 3 golden rules to guarantee top marks on these papers. Rule 1. Command word decoding. You have to know what evaluate means versus describe. Rule 2. Peel framework application. Use point, evidence, explanation, link for every single extended answer you write. And Rule 3, the time management matrix. Spend your minutes where the method marks are the heaviest. Don't waste 10 minutes on a 2-mark question. Burn this sequence into your memory. This is your surgical checklist.
So, I leave you with this final, provocative question. Will you walk into that exam hall and rely on superficial facts like Alex, hoping to just scrape by? Or will you use a methodical, surgical framework to absolutely master your next examination? The choice between surface-level memorization and deep, evaluative thinking is entirely up to you. You now possess the blueprint. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep refining your frameworks, keep practicing your past papers, and I'll catch you in the next explainer.